Hello everyone. In this video, I will talk about how you can convert the colored images into grayscale equivalent and how to create many binary images out of it. Before we move ahead, if you want to learn about basics of MATLAB, like how to create sections, like I have done in this code, and understand how different windows in the UI works, you can access the playlist named Basics of MATLAB on my channel. In the first section of code, line 2 and 3, I have read an inbuilt image in MATLAB named colored chips using IMRead function and displayed it using the IMShow function. On running the first section, the colored image is displayed. In the previous video in image processing playlist, we discussed that this colored image has RGB color planes in it and how we can extract them. In the workspace window, the size of the image is displayed as 391 into 518 into 3. The 3 at the end indicates the RGB intensity values information in the image and increases the memory consumption. This also leads to increased time in running the algorithm, so in general we prefer to work with grayscale images. A grayscale image has the information about the intensity value of each pixel, and these are computed as weighted sum of intensity values in RGB plane. Section 2 of the code from line number 5 to 7 shows the conversion of colored image to grayscale equivalent. We make use of inbuilt IM to gray function of MATLAB to convert the image. On running this section, so the grayscale equivalent of the image is displayed. In the workspace window, now you can see that the size of image has changed. Grayscale images not only saves the memory, but it is also simpler to build algorithms for it since it is essentially a 2D array now. The binary image has only two pixel values, that is 0 and 1. So to convert the grayscale image into binary images, we need to understand which intensity bin has how many pixels in it. In a grayscale image, we know that the intensity values can vary from 0 to 255. So let's plot the histogram of the image and see which intensity value can be set as an threshold. To plot the histogram, we can make use of imHist function of the MATLAB. So let's first add figure command on line number 9 so that the histogram opens in a new window. Now on running line 9 and 10, we can see the histogram. Now in this histogram, I have picked the point which is marked by X 141 and Y 413. So basically the intensity bin 141 has 413 pixels in it. This point seems appropriate to me for thresholding, since after this the pixels with high intensity values start to increase. On setting this X value, that is 141 as threshold, all the pixels below that threshold will go down to 0 and above it will be changed to 1. Now let's set this threshold on line 12 and plot the binary images using IMShow function. And this threshold works as for MATLAB, the image is simply a 2D array now. MATLAB also has an internal function that converts grayscale images to binary, and in the next section I have done that. So this function will automatically choose the best threshold value, and name of the function is imbinarize. This last section of the code loads the binary images created using imbinarize. Let's run this section now. Now let's create a new section and compare the two binary images we created using manual thresholding and using the imbinarize function. So this new section is named as images comparison, and I'm using montage function which I talked about in the last video. This can be used to plot two images side by side. I am sure we'll only plot one image, but using this we can plot two images. Or simply if we provide montage as an input to the I am sure we can do that as well to plot the two images side by side. So now you can see both the thresholding works almost equally good in this case. This completes the topic for our today's video. So thank you everyone. And if you want to learn about how to read images in MATLAB and extract the color planes out of it for filtering, do watch our previous video in image processing playlist.